Vectors, Part 1, Algebraic Vectors. What is a vector? Now, if you have studied vectors before, it very well is in the context of physics. So a vector is something that has a magnitude, how big it is if you would, and a direction. And often in physics, vectors are represented with arrows, which I would call a geometric vector, something I will talk about in the next video. But here we want to look at just the algebraic side of it. So physics usually says a vector is something that has a magnitude and direction. But for me in mathematics, I say a vector is simply what? Well, it's simply a list of numbers. That's really all that is. And there are different ways of writing vectors or different notations. Some of the common ones are like this. We see like 2, 4. It looks sort of like a coordinate point, and it's related to a coordinate point. We could also put in notation like this. I'm giving this more dimensions, if you would. And if you study matrices, it looks sort of like matrix notation. In fact, that's what it is. We call that a row vector. But it could also be written in another form, like 2i plus 4j plus, say, 3z. Now, 3k. So, of course, what I've done here is I've given 3 different vectors. They're not the same thing, but just 3 different forms of writing vectors. So what is a vector algebraically? Well, let's look at the example 2, 4. And let's go and plot the point 2, 4 on a coordinate system. So 2 on the x, and then 4 on the y. So the point 2, 4 is not the vector. The vector is the arrow that points from the origin to that point. So the point is 2, 4. And then the vector is the arrow from the origin to the point. Now, do all vectors start at the origin? The answer is no. But if I write a vector in this form, then it's assumed that we start at the origin. For example, if I wanted to draw the vector, say, -2, 1, then now I'd find the point -2, 1, and draw a vector from the origin to that point. But I could also say a vector something like this, and I'll call vector v. Very often when we write vectors, we put a little arrow on top of it, like that. I might say that v is the vector from, say, the point 1, 1 to the point, say, 3, 2. So if I tell you where I start and where I go, then I don't start at the origin. Let me draw that real quick. So here's a point 1, 1, and then there's the point 3, 2. And then vector v would be that vector from 1, 1 to 3, 2. But if I don't tell you where I start, if I just put notation like this, it is implied that we start at the origin. So vectors are pretty simple concepts, this list of numbers. Let's get another coordinate system going up here. Draw some axes. And then let me redraw the point, or the vector 2, 4. So 2 on the x-axis, and then 4 on the y-axis. So 1, 2, 3, 4. And since I don't tell you where it starts, we're going to assume it starts at the origin and points toward that point. Now, I could write this, as kind of alluded to earlier, as the vector 2i plus 4j. Well, what does that mean? I is what we call a unit vector. A unit vector is a vector with a magnitude or length of 1. And very specifically, I is the unit vector 1, 0. That is, it's this vector down on the x-axis. Let's change the color so we can see it. That'll be I right here in red. And then j is also a unit vector, but it's a vector along the y-axis. It is the vector 0, 1, which I'll draw in red over here, like that. So, if I want to write 2i plus 4j, what am I saying? I'm really saying I want to go 2 in the direction of I. So 1, 2 in the direction of I. And then I want to go 4 in the direction of j. So instead of going straight up the axis like this, I can start here and just go up 4 in the direction of j. So 1, 2, 3, 4. Like that. And then the vector 2i plus 4j is the vector that takes the shortcut across. So instead of going 2 down here and then 2 up, which we do, the actual vector is the vector that takes a shortcut from the starting point to the end point, which of course is exactly the same vector we got before when we plotted 2, 4. Let's do another example of this. Let's draw the vector, let's say 3i minus 2j. And I'll call this vector u. I just want to reinforce the concept of the I and the j. So 3i says, let's go 3 in the I direction. So I, remember, is the unit vector down the x-axis. So I'm going to go 1, 2, 3 down the x-axis. And then minus 2j. So minus 2 means I'm going down along the y-axis in the y direction. So I'm going to go down 1, 2 in the y direction. And then the vector u is the one that takes the shortcut from where we started to where we finished. Just like that. Which, of course, is the exact same thing as the vector 3, negative 2. Now, I've done some things in here that are implied. I didn't explicitly say we could do this, but it's pretty intuitive, and now I'll talk about some of these things directly. The first concept of a vector, because a vector is something that has a magnitude and a direction, and it is important where I start. But roughly speaking, any two vectors that have the same length, the same magnitude, and point in the same direction are the same. So here I drew the vector 1, 3. Notice I could have started somewhere else. Let's say I'll start over here at 4, 2, and gone 1 to the right and 3 up. They're not the same vector, but equivalently, they basically are. And kind of depending on the circumstance, they exactly are the same thing. In other circumstances, they're not, but that's a really kind of beyond the scope of this course. But the big idea here that I want to talk about is that if you have a vector, you can essentially move it where you want, and it stays the same as long as you don't change the length or the direction that it's pointing. So all of the vectors I just drew are equivalent. The other thing that I implied, very highly implied, was how do we add two vectors algebraically? So when I did the problem 3i minus 2j, what I really did was 3 times the vector I, remember this is 1, 0, minus 2 times the vector j, which is the vector 0, 1. I also implied how we can multiply vectors by a constant. So if I want to multiply a vector by a constant, for example right here, 3 times the vector 1, 0 simply becomes 3 times 1, comma, 3 times 0. That is, I can multiply this coefficient, this number out front, by each of my components individually and just leave my comma there in between. And then minus, now I'm going to multiply the 2 times each of these components. So minus 2 times 0, which is 0, comma 2 times 1. Now, how do I add, or in this case subtract vectors? Well, you might have guessed already. We just add or subtract the like components, in this case the x's, together. So I have 3 minus 0, which is 3, comma, and then now I add the y's. 0 minus 2 gives me negative 2. Now, I did a lot of work there for something really simple. So let's just do some simple examples where we multiply vectors by a constant and then add them together. So let u equal the vector 4 comma negative 1, and v equal the vector negative 2 comma 3. Equivalently, I don't need it for this problem, but I could have written u as 4i minus j, and then v as negative 2i plus 3j. But let's look at this form right here. What if I want to find 2u plus 5v? How would I do this? Well, very simply. Let's multiply 2 times u. So I'm going to multiply 2 by each of the components of u, giving me 8, negative 2. And then I'm going to multiply the 5 by each component of v, giving me negative 10, comma 15. And now I want to add these two vectors together by adding the like components. So I add the x's, giving us 8 plus negative 10, or negative 2. And now we'll add the y's. Negative 2 plus 15 is 13. So 2u plus 5v equals negative 2, 13. Let me do one more example here. Let's do negative u and then plus 4v. Same u and v as above. I'm going to do this quickly. Negative u is what? Well, it's negative 4 comma positive 1. 4v is going to be negative 8 comma 12. Now we add like things together. Negative 4 plus negative 8, comma, 1 plus 12, 13. And that's how we handle vectors algebraically.